All right.
Yeah.
So that's mensuration. Talking about measurements of volumes, of area, of perimeter. This aspect of geometry. Mensuration. All right. This first question says, a frustrum is made by removing a small cone from a similar cone. The height of the small cone is 20 cm. The height of the large cone is 40 cm. The diameter of the base of the large cone is 30. Work out the volume of the frustrum. Give your answer correctly through significant figures. Yeah. By the way, as already stated, you get a frustrum by removing a small part of a cone from a bigger cone. Like this stuff that they use for serving ice cream. Small, like a pocket, you understand what I mean?
Yeah.
A cone, it doesn't have this pointed end. It just looks like a cup, Of course, a cup is, some cups are designed to look like a frustrum.
Yeah.
All right, so what do we do to find the volume of the frustrum? Only this part. What do you think we should do, first of all, if we need to get the volume of only this part? The volume of only this part, what do you think we should do? Yes. Don't you think if we find the volume of everything, this entire big cone, the whole big cone, and then we remove this part that has been cut out, whatever is left is the volume of the frustrum. Can I say that again?
Yeah.
The entire volume of the big cone, the entire cone. We first of all find it. And we find the volume of this small part that has been cut out. And then we take it out. In other words, remove it, subtract. Whatever is left, the remainder is, whatever is left is the volume of the frustrum we are looking for. Do you agree with me?
Yeah.
So we need to find the volume of this entire big cone. What's the formula for the volume of a cone?
I don't know.
Okay. A cone is like a cylinder divided into 3 equal parts. You know how a cylinder is? Sorry,
Yeah.
I'm taking up so much space. I think I need to reduce this. So if we have a cone, a cylinder like this, this is a cylinder. You know what a cylinder is?
Yeah.
A cylinder is actually is an example of a prism. I hope you know. What's a prism, by the way?
A prism is. I know what it is, but I don't know how to explain it.
Yeah, a prism is a solid with a uniform cross-sectional area.
Yeah.
So I just draw a line here to define it, just to remind you. A prism is a solid or a 3D shape. 3D shape. 3D shapes are solid.
Yeah.
With a uniform cross-sectional area. I need to write a solid better. With a uniform cross-sectional area. Cross-sectional area. Uniform cross-sectional area means from one end to the another end, it looks the same way. A cylinder is an example of a prism because this area here, I will hash it with green. This area here and this area here look the same and are equal, so it's a prism. Perhaps you can compare it with this. In fact, a frustrum is not a prism. Let me just show you. Can you tell me why this is not a prism? Scroll up to where you have the frustrum. Why is it not a prism?
Because
the two cross-sectional areas up, down are not equal. You know. In fact, we normally name prisms by the shape of the cross-section. Like this one is circular, so you can actually call this circular prism. A circular prism is a cylinder, right? So scroll down to where we have the cylinder. So a circular prism is a cylinder. Are you looking at my drawing?
Yeah.
You can have triangular prism, rectangular prism, and so on. I just said to mention that. Do you remember the formula for the volume of a prism? So I say a cylinder is an example of a prism. Good. A cylinder is an example of a prism. Yeah, what did you say is the formula for the volume of a prism?
Area of cross-section times length.
Yes. Area of cross-section times height, which could be distance between the two opposite ends. So volume of every prism is equal to cross-sectional area, or area of cross-section, times height or distance between cross sections, because it may not be a vertical height, it might just be a horizontal height or distance between opposite ends, opposite cross sections. That's opposite cross sections. Okay, so if this is a circle with radius r and the height is h, what's the volume of this prism, which of course is a cylinder?
Pi r squared times h.
Pi r squared times h, because the volume of this cross section, which is a circle, is pi r squared. The distance between the cross section is h, so the volume will be, volume is pi r squared h. V is pi r squared. Pi r squared stands for the circle, then times the h, which is the distance between the cross sections. Remember, volume of a prism is area of cross section, in this case is circle, times the distance between them. All right. So we can actually get a cone from a prism. If we divide a prism into 3 equal parts, we have a cone. So I'll use this to divide it like this. 3 equal parts, you have a cone. So what should be the area of a cone? A cone is a prism divided into 3 equal parts. A cone is a cylinder, actually. I didn't say it's specifically a cylinder divided into 3 equal parts. Divided into 3 equal parts. So what should be the volume of a cone? if it's a cylinder divided into 3 equal parts?
Pi r squared h divided by 3.
So therefore volume of cone should be equal to volume of cylinder divided by 3, pi r squared h divided by 3. Divided by 3. So that's how we can get the volume of a cone. You know. So I'll just read a line here before we develop this further. Alright, of course there are different other examples of a prism. I've told you about triangular prism and all that, but let's focus on what we are doing. If I had the luxury of time, I could have drawn a triangular prism. Let me just show you. And that's the one most people know as prism, but that's not the only prism. There are other kinds of prism. So I might decide to use that, draw this, you know. And of course, that's also a prism, you know.
Yeah.
So if you want to find the volume of this particular, by the way, what would you call the name of this prism? Triangular prism. If you want to find the volume of this prism, what will you do?
Half times base times height.
That, beautiful. So we find the area of this triangle. Perhaps I can call it triangle A, B, C. Find the area of triangle A, B, C. And that's a cross section. And then how do we find the entire volume of this prism?
Times it by the length.
By the length, which assuming it is L. So this will just be divided by L. No, multiplied by L actually. The area of this cross section multiplied by L, because L is the distance between the opposite ends. So remember, the volume of a prism is area of cross section times height, or distance between opposite ends. Area of cross section times the distance between opposite ends. Okay, so that's how we're able to get the volume of a cylinder, pi r squared h, and from there we got the volume of a cone, which is a cylinder divided by 3. Now we can move forward to get the area, the volume of. I need to get this diagram to another place. Let me see if I can import it to another page where we can have a bigger space. Just a moment. Let me create another page for it. We need a bigger space to deal with it. So I'll pick it from here, take it to a bigger page. All right, I'm on the next page. I'm on the next page. Okay, so you can see it.
Yeah.
Remember, can you remind me again how I said we can find the volume of this frustrum? The frustrum is just the part that we need. How can we find the volume of the frustrum again?
You find the volume of the whole big cone, you find the little one at the top, then you take one.
Beautiful. We find the volume of the whole big cone, and then we find the volume of this top part that has been cut out. Once the top part is cut out, the remaining thing is now a frustrum. So we need to find the volume of the big cone. Can we start with that? Volume of the big cone. So you now understand why I did all that I did to get you to understand the formula for volume of a cone. Volume of big cone. What's the formula again?
Pi r squared. Pi r squared.
Pi r squared h
divided by 3.
Okay, so which is equal to pi. You can leave it as pi. You can punch it in your calculator. What's the radius?
15.
Good. It's good that you discovered that, because this whole place is a diameter 30. So the radius is 15. I think I need to indicate that. Let me indicate it in the drawing. We even need it in our further analysis. The radius is 15 cm. Alright, so times 15 squared times h, which is 40, all divided by 3. Can you get us the answer first of all? Let's start with that. Do you have the answer now?
Yeah, almost. I got 3,000.
3. Just read out the digits.
Do you want a decimal or pi?
Yeah, everything. 3,000
pi.
Oh, 3,000 pi. Please, can you multiply it by pi and let's have what it is? I don't want the pi to be showing because they didn't ask us to leave the answer in pi. So pi is 3.14, by the way.
No, I can already press another button to make it notice.
Okay, you could just multiply the 3,000 by 3.14 or 3.142.
It's 9,424.
Pi is 3.142. So everything is what now?
9,424.
9,424. 0.79, right? 98.
0.78.
Okay, 78. Okay, let's just leave it here. cm cube. That's the area of the big cone. So we need to find. Sorry, that's the volume of the big cone. We need to find the volume of the small cone that was cut off. But we need to apply some interesting geometry to do that. Did you see what I just drew? It will show at your end.
No, it's showing.
Is it showing now? Alright, I'm going to call here. I'm going to call this A, B, C, D, and E. We have two triangles here. Can you identify them? We have two triangles in what I'm circling.
Oh yeah.
Can you identify them? This one I'm circling. This one on the right hand side that I'm circling. We have two triangles there. What are the triangles? CED. Okay, so let me write it down. Consider triangle CED, and triangle AEB. Okay, I'm impressed with the way you're naming it because you're naming it accordingly. AEB, because you said CED for this smaller triangle,
Yeah.
and then you need to name the bigger one accordingly. AEB for this big triangle. Can you see that they are similar?
Yeah.
They're actually similar triangles or similar shapes. Because they are similar, their sides are corresponding. Consider triangle CED and triangle AEB. Alright, so I can add that these are similar triangles. These are two similar triangles. You know, whenever you have similar shapes, you can compare the sides. These are two similar triangles, yes. So I'm going to be taking care of the big triangle. That's triangle AEB. Then you will take care of the small triangle, triangle CED. So any side I mention for the big triangle, you need to mention the corresponding side for the small triangle. Can we let's do the game. I will start with my big triangle. Remember, I have the big triangle to deal with. Then you have the small triangle to deal with. I'll mention a side in the big triangle, you mention the corresponding side. So I mentioned AB.
CD.
So AB is proportional to CD. Alright, also if I mention AE,
CE.
so you will mention CE. CE. Okay, and if I mention, what's the other side remaining? BE.
DE.
If I mention BE, you can mention DE. So those are corresponding sides. And so because they are corresponding sides, AB over CD is equal to AE over CE is equal to BE over DE. That can help us to get whatever we're looking for. By the way, what's the value of C to E?
C to E is 20.
It's 20. It's given. C to E is already given as 20. In fact, can we fill in some of these values and then begin to use it to find whatever we need? AB is 15, isn't it?
Yeah.
So I can write 15 over CD. We don't know what CD is. So you may just want to call it CD. It's equal to, do we have AE?
Yeah.
AE is what?
40.
Okay. A is 40 over CE.
20.
C is 20. That means we can actually use this equation to find CD. Isn't it?
Yeah.
Or to even find other ones, maybe later. By the way, you know you can find this. How will you find EB or BE?
How about what?
How will you find B to E?
Pythagoras.
You can use Pythagoras theorem to find B to E. And then you use the ratio to find the remaining one, D to E. Okay, but I think what we focus on is just this, because that's what we need for a reason. I will tell you why. So we just find CD. CD will give us the radius of this small cone that is cut off. Because when we have the radius of the small cone, we can find its volume. So let's find CD. Well, 15 over CD is equal to 40 over 20. Remember how we came about all that? Ratio this equal to ratio this equal to ratio this. Are you clear with that? Are you? Yeah, you clear on that. All right, so let's find CD. Let's find CD. So what's CD? You just cross multiply now, isn't it? Okay, let me do that so that we don't jump the gun. Cross multiply. Whenever you have something like this, you simply cross multiply, okay?
Yeah.
CD times what?
40.
40 CD is equal to 15 times 20. So what's CD? 15 times 20 divided by 40. So what does it give us? What do you have?
7.5.
Please, can you speak up?
7.5.
7.5 cm. So we found CD, and CD is the radius of the small cone. This small cone here, that's the radius. The whole small cone here. So can we now find the volume of the small cone? Can we now find the volume of the small cone? Are you ready?
Yeah.
Volume of small cone. You know the formula for the volume of a cone? Pi r squared h over 3. So that the volume of the small cone will be pi times, what's this r?
R is
The radius of this small cone.
7.5.
7.5, which is what we found, times 20. Let's show us how we came about it. Pi times radius, which is 7.5, times the height, 20. The height is 20, the radius is 7.5, we've just found, divided by 3, of course. We divide by 3 to get the volume of a cone. Okay, so what does that give?
$157 point.
157 point. I hope you took care of the pi and all that.
Yeah, 0.8.
0.8 cm cube. So now what is the volume of the prism? Volume of the frustrum? Therefore, volume of
9424.78.
Therefore, volume of frustrum equals, we said it will be volume of the big cone, subtract volume of small cone. Volume of big cone is what?
9,424.78.
9424.78. Take away minus 157.08. So we give the answer to 3 significant figures. That's why I'm leaving the answer to more than 3 significant figures, so that the final answer will be in 3 significant figures, right? Anytime you're asked to leave the answer in 3 significant figures, the working should have more number of significant figures, at least from 4 or 5 is fine, because the final answer should be to 3 significant figures. So what's the final answer?
It's 9,260.
9,260.
9,267.
60 what?
9,267.7.
Okay, so since we are interested in 3 significant figures, what will it be?
927.
No, it was a 9,267. So you can't just turn it to 900. Three significant figures. It means you are stopping where? What? First, second, third. This is where you are stopping at. For three significant figures, you are stopping at 6. The next one is already more than 5, so you call it 1 and add to this. So it becomes 9. Oh, we don't have enough space down here, so let me write it up here. 9, 2, 6 will now become 7. You remember now? The next.
That's what I said.
Okay, but then there's something you didn't take note of. Whenever you are rounding off a number, before you get to 0, any other number following should be written as 0. You know, you actually said 927, but it is actually what?
9,270.
9,270 cm cube. All right.